Hello friends, our chapter is petrochemical and eco-friendly fuels. Now the chapters you have to study basic concept of the fuels. What about the definition of the fuels? Fuels are the naturally occurring, that is the combustible organic substance. After burning of the fuels, so that can be obtained the heat energy that is used for the chemical industries as well as domestic purpose. Now fuel is the source of energy. Fuel is the substance which by oxidation is made a source of heat for practical purposes is called as fuel, or any combustible substance which may be burned to supply heat that can be used economically or domestic and industrial purpose. So these are the different types of the definition of the fuels, and fuel are the very important materials which are used in the industrial purpose as well as domestic purpose. It is the one of the source of energy in the fuels. Now in today also electrical energy, nuclear energy, this is also the source of energy, and that also considered as a fuels. Now generally solid fuels, liquid fuels, gaseous fuels, these are the different types of the fuels. In the solid fuels having the coal, wood material as well as lignite as well as that is also the charcoal, wood, coke, briquettes. These are the materials which is artificially that can be produced from the coal, and this is the coal is the basic solid fuels. Now in the liquid fuels, naturally gasoline or the crude oils containing petrol, kerosene, diesel oils, petroleum, coal tar, alcohol. These are the products which is obtained by the artificial process. Now the gaseous fuels, that is the natural gas, producer gas, water gas, oil gas, blast furnace, LPG. These are the some of the artificially they are produced, but basically natural gas is the methane gas. It is the one of the source of the gaseous fuel. Now primary fuels, fuels are directly obtained from nature is a primary fuel. Wood is the material generally, that is the primary fuels, and secondary fuels are the that materials produced by processing primary fuels in the converted in the petrol, converted in the diesel, kerosene as well as coal tar powder. These are the some products which is obtained that also act as a fuel, that is known as the secondary fuel. What are the properties of the good fuels? Generally, first is the high calorific value. The calorific value of the fuel is the amount of heat produced by the complete combustion of the unit weight or unit volume of the fuels. Now this is the one of the definition. After the fuels can be burned, what about the energy can be produced, and that you consider as the calorific value. Now the calorific value is to be more useful to the properties of the good fuels. That fuels are having the high calorific value, that have to be produced the large energy, and then this also have to be measured by the different types of the units are there by the measurements of the that types of the calorific value, and it containing in the high calorific value, it is the most important property. Another is the moderate ignition temperature. Now any types of the fuels that supposed to be burned, and that is the not in the fast burning, not in the slow burning, but it should be the moderate burning or moderate ignition, and in the ignition time that also have to be moderate. Now it can be catches the fires and it can be continued burn without further heat is called as ignition temperature. Now this is the shows as the one of the ignition point is to be noted down, and that like to start the burning, and after that without produce the energy or it can be continuously burn, and that is the moderate ignition temperature is very important. You consider by the any types of the fuels, and that fuels are the have to be considered by in the that also in the storage transportation, as well as it also like to start their ignitions. So this all can be supposed to be considered in the form of the moderate ignition temperature is one of the very important property. Now another is the moderate velocity of the combustion. The temperature attained by combustion in the case of the particular fuels, and that fuels it has to be depends upon the velocity of the combustion. Generally the calorific value it has to be depends upon the that is the type of the fuels, but you consider that rate of the burning of the fuels that should be not as low, not as very high, but it should be the moderate, and that you can also determine the rate of the combustion also, as well as this also the temperature you also note down, as well as that in the application of that types of the fuel it also have to be very easy. Otherwise when it is a low of the there is combustion, high of the there is a rate velocity of the combustion, and then it is not as a good fuels, but moderate velocity of the combustion it is very good quality of the fuel. Now fourth property, the low percentage of non-combustible matter. That matter is to be generally present in combustible and non-combustible. Both the types of the substance are present, matter is present, and generally in those are the good quality of the fuels. That percentage of the non-combustible matter that should be the less, or it not like to be there. Only in the more combustible matters that's supposed to be present, and it also have to be produce very large of the heat, and this is also the good quality of the fuels. Another is the product of the combustion. Now generally after that fuels can be burned or it get their combustion, it should have to be formed in the different types of there is a compounds which is to be obtained. Sometimes there are number of you considering there is some gases, toxic gases, some of the like as the carbon monoxide, sulfur dioxide, hydrogen sulfide, phosphine, these are the gases which is obtained. That is very harmful. So we consider in the any types of the fuels, so it does not obtain the toxic gases, it does not like to be formed in the any types of after the remaining burning of the fuels. Those are there is a non-combustible matter is present. This is not harmful, this is not poisonous, and this is also the one of the good properties of the fuels. Another is the easy to the transportation. Now the good fuel is easy to handle, easy to store, easy to transport, as well as this also have to be easily shifted from one place to the another place. No any difficulty can be there, and that you remember as a good quality of the fuels you remember, as well as seventh property, the low cost. This is very important. Fuel should be readily available in the bulk at low cost. The cost of the production, storage and transport should be low, and it is to be very easily available, as well as cost is also have to be less, and in the bulk quantity that's supposed to be available. These are all of the properties of the you remember in the good quality of the fuels. You're supposed to ask in examination. All the seven properties supposed to be right. Those fuels are all the burning substances. It is not a fuel, but it should be like to obey these all the seven properties, and then you can say that fuel are the good quality of the fuels. It is also the selection criteria is also important. Now it must be that is the reasonably high velocity of the combustion, as well as it should be high calorific value, as well as it having the proper ignition temperature. It must have the low percentage of non-combustible matter, as well as it must have low cost, and it must be available in sufficient quantity, and it must be the easy for transportation. So these are also the all the properties are there. In short, this is all are the criteria of the good quality of the fuel. Now calorific value is also asked in the examination. What is the definition is there? Now this is the fuels having the different calorific value, and calorific value is defined amount of heat liberated in calories by the complete combustion by combustible substance with oxygen and the condensation of the products to the desired temperature. Now the amount of heat can be liberated. You remember it is to be measured by the BTU, British thermal units, calorie, kilogram centigrade unit, KCU, kJ per gram, kilojoules per gram. These are these units which is to be interconversion of the calorific value is to be determined, and this all the units that supposed to be interconverted to each other. Now this is the calorific value is to be determined. Amount of heat produced is equal to M into S into T. There is the mass of water. S is the specific heat of water, T is the rise in temperature of water. Now this is the formula is to be there, amount of heat produced. After this have to be added in the calorific value is equal to amount of heat produced by mass of fuel, and that Q into X joules per gram or Q into X into 1000, that is the kJ per grams. This is you consider as a calorific value is to be determined in the form of the kilojoules per gram or the joules per gram by using of this formula. Sometimes the problem is also asked in examination. You determine the calorific value by given in there is a number of values are there, and one value is to be unknown. You supposed to be determined by their interconversion of different units to each other and find out what amount of energy is to be liberated. Now this BTU, British thermal units, it is also have to be expressed in the calorific value, that is considered as water is the standard, and that chemical reaction, what about the energy is existed in the outside and it is compared to the water, and water is considered as standard, and with help of the water you have to determine the British thermal units value by the form of the calorific value. Calorie is the one of the unit. This also comparing the water is there. This is also in the form of the kilocalories. Calories. These are the units which is to be given by this formula of the calories. KCU, kilogram centigrade units. This is also given to the interconversion. Is also comparing water is one of the standard, and this calorific value is to be determined in the form of the kilogram centigrade units is there, and another is the kilojoules per gram. This value is to be expressed as a kilojoules per gram. It is common unit of the measuring the calorific value, that is mostly this kJ per grams. This is a generally used in to the expression of you remember in the form of the calorific value. So these are the all types of the values as well as units which are used. Measurement of the calorific value is there. So some types of the material which is present in the naturally or artificially, you also determine the calorific value. Cow dung material, and this is the wood material, coal material, charcoal is there, alcohol, diesel, kerosene oil, petrol, biogas, natural gas, LPG, methane, hydrogen, nitrogen. These number of the gases you supposed to be like to determine by their values are there. Calorific value in the form of the kilojoules is one of the standard units are there, and different of the material have the different value. They are depending on what about the organic compounds which is present in that material and how it is to be burned, and it is to be given by the burning that can be produced the amount of the heat, or all are having the different types of the calorific value. Other properties of the fuels, generally in the ignition temperature, the temperature at which the fuel catches the fire and continue to burn without further heating. So this is also asked in examination. Ignition temperature, one time burning, further no burning, no requirements of the burning, and that have to be continuously burned, and that is known as ignition temperature. Ash point, it is the property of the liquid fuel, the minimum temperature at which the sample of fuel catches the fire. Now you consider in paper, you consider in plastic, you consider in the vegetable matters. They all are having the different types of that flash point is there. Sometimes it require more heat for the light to flash. Sometimes it is lower heat is required to the flash. So that time is known as the flash points, and that is to be burned in presence of the oxygen. Fire point, the temperature at which the fuel catches fire and continue to burn, containing more volatile fuels are there. Generally, more volatile fuels which is present in the materials, and it has to be continuously burned. More non-volatile matter is there, so it is not burned, you remember. Coke number, amount of carbon is present by weighted sample of the fuels. Generally, in the calorific value is to be also depends on what about the carbon is present. More carbon is present, more of the calorific value. Hence the Coke number, amount of carbon present by weighted sample of the fuels. There is more carbon is present, then the more calorific value. Octane number, the ability of the fuels to resist knock in the gasoline engine that needs high compression ratio. Generally in the petrol engine, that is the octane number is very important. Octane is the carbon 10, and that have to resist the fuels in the, you remember, in the knocking process. That is the anti-knocking agents that's supposed to be present, and that have to be get the one of the beneficials of the engine. That has to be soft running of the engine by petrol engine. Octane number is to be like to, there is a in the ratio of the octane number is to be find out and need to be used in that engine. Cetane number is also in the diesel engine. It is a measure by the ignition time of the fuels. It also slow burning process, you remember. And cetane is the diesel engines. So octane and cetane both are different. It is to like in the firing of the engine, it has to be controlled by the